We've got Skype happening right now. There's a number of people I need to bring into the conversation if we wish to do that. There's one, two.
Yeah, we're three
or four on Skype, and we have two other people than myself right here, right now, live as well. And there's other people that will probably come on Skype. I'll put on Lady Dragon. She's Lady Dragon, yes. I thought you might have run into her before. She's quite a character. I've just recently made contact with her. We also have a live feed for Justin TV right now. And there's, how many people on the Justin TV? Does it say 5 or 6 or something?
Hello, Rick.
Hi.
Where can I
Hi,
find
Lady Dragon.
Hi, Rick.
I can hear you. Can you hear Lady Dragon, Mehran?
Yeah.
Okay. Well,
hello, Mr.
Hello, good morning.
Good morning. Very pleasure to talk to you, sir.
Nice to talk to you as well.
Lady Dragon is, she has a website in Montreal and an internet radio show as well. And she's, would love to talk to you about a few things and has some comments and ideas and so on that she'd like to discuss as well. Can you tell a little bit about yourself, Lady Dragon?
Yes, well, I've been around for a while, for like over 15 years. I existed before Google. So therefore, when I write an article, Google picks it up and put it in Google News. And I'm known all over the world, in every single country in the world. And I like to spread the truth about forbidden knowledge and things that people that don't want things to know. I like to talk about that to people that listen to me, are people that are very awake, they are very knowledgeable people. And I believe that you're doing a beautiful work, and I want to talk about your great work, you know what I'm saying? And I have opened a specific section on my website, which is ladydragon.com. And I talk about all your great work, and I talk it about on my radio show as well. So that's what I wanted to talk. I wanted to participate in this because I believe the world is changing to a better place, and I want to participate into the change. You know what I'm saying?
Yes, no problem. You're testing a reactor.
Kind of, yeah. I stopped, my last email, and I'm just waiting to see. Otherwise, everything is ready, so I can do it even tomorrow.
I have some concerns about your system.
Mm-hmm.
I would like to see them before you load, because
Yeah.
I've seen the things you've done.
I don't know if
can we have a live connection?
Yeah, I hope so. Let me see how the...
You're coming up, yep.
There it is, yeah.
You're there, don't do anything.
Here is the...
See you.
Yeah. Here is the system. Here is the balloon for filling. This is the first valve. This is the 5 centimeters tube.
Can you take it more? Can you take it more in the light? The light is in the wrong position. Move your light in a different direction.
Is it better now? No.
No. The shadow is on the system.
That's a little better.
Okay.
I don't know if I be the background.
Yeah,
Maybe it's
okay.
better. So this is the 5 centimeters tube. This is the 3 centimeters tube. This is the inside the jar. There is a magnet steer rod, and I'm planning to steer it inside just to see if I'm gonna get the scintillation from that. What do you think?
You should not see the scintillation. If you see the scintillation, it means you're going to get irradiated.
Okay, so...
the scintillation, especially the way you are doing it. Do you know what the scintillation? He's disappeared.
Yeah, I turned off the video. Yeah, I turned off the video not to.
Yeah, the thing is,
the connection.
The strength of scintillation is just on the X-ray strength. This is what we call a soft X-ray. So you expose yourself just on the possible X-ray radiation in a low level. So it's not such a good idea to see it this way.
Well,
Once you create it,
the planning is to watch it on the TV. I won't be anywhere close to the reactor. I'm gonna be about 30 meters away. So my idea was just to see if I can achieve these conditions you are talking about.
What are you planning to put in that glass jar?
I have so far helium and hydrogen. I can get my hands on argon, but neon is very expensive here, so I cannot do anything about neon, at least at this point.
The thing is, if you use helium, you bring the conversion too close to the glass. Use a third gas or a fourth gas to contain any soft radiation as a shielding itself. Then you will see it. But the problem is if you have a fast rotating magnets, the way I saw it in there, if they are loose, or if your magnet goes loose, your glass will open up. That's it. I know that for a fact. So
is fix them.
Yeah, you got to fix it, but it doesn't work, unfortunately. It doesn't matter what rotation you put on it. A lot of people are using centralized magnets because it's on the patent. I even see it behind Rick on the wall. You should create you should create a magnetic field through material, not through solid magnet. The minute you put magnet or matter in touch with your plasma, you'll find out your magnet disappears because it becomes like a hole, a wormhole, and it literally destroys the condition of the plasma the way you like it, or you can keep it, unless you can produce vast amount which continuously get disappeared. But you have to use, if you're using a glass tube, we talk about plastic and glass, but then you have to use what you call a magnetic shielding, or you use an argon or whatever you have in the outer boundary, but you have to keep the condition of the vacuum high enough that when you add material to it, you're not a vacuum condition anymore. You are a balanced condition. This is some people I read, I listen, and I see emails coming to me. They talk about what vacuum condition you use. -10, we go to -9, -10 bars. But
my pump can go down to -4.
So you'd have to use a turbomolecular pump or something like that, or a diffusion pump in order to get to that level. Is that correct, Mr. Keshe?
I use combination pumps. You use a combination pump, you vacuum through molecular in the last stage, but once you put the first atom in, your condition of vacuum is not vacuum anymore. So you change, you become what I call contaminated. And if you read book, I think 1 or 2, I explain even in the vacuum of the best vacuum, there is still materials. So the way you have to load up your system is what I call a hydrogen wash. First of all, you sterilize your systems thoroughly. That is, you sterilize them, that there is no fat. You never use hand to handle your reactors. You always use disposal gloves. If you assemble the system without disposal glove, you find problems because it's like a fingerprint. Fingerprint is fat. So the fat can convert into hydrogen, nitrogen, what you don't need in your system. To try to work in a very clean environment, and what you do, you clean it with alcohol of a very, very high level of alcohol, purity, 90-95%, that level, and you allow it to evaporate in a container, not in the open air, that it doesn't absorb more rubbish on it. Or you work within a container which is a vacuum condition or clean condition, and then you assemble your reactors always with gloves, with glove. And if you by accident touch something else, change glove. In one experiment, I use up to 50-60 gloves because it doesn't matter. The reactor has to be thoroughly, uncontaminated as much as possible. In a mass production, you make your systems in a way you don't get contamination. But in trials and the system like which I use, I open my reactors maybe 10-20 times in a day because I want to see different combinations. So you have to be always aware. If you put a reactor together or your system together, use your hand, go back, clean it before you assemble it, because then you see the problems in the future stages of the work. So when you do that, try to use inert gas shielding. Inert gas shielding gives you a lot of advantages and much more rapid ionization because they themselves participate in it.
Mr. Keshe, does that require the reactor core to rotate, or are there better ways to do that procedure?
We have tried every possible, combination. And in some, it depends what you want from your reactor. You get different parameters, you get different performances. For some tests, you can use central rotation core. This is for mainly lifts. It's very, very nice to be able to use. For energy, you don't use that kind of thing. Use the other point. Some people try double rotating cores. Double rotating cores are one of the most powerful systems.
So you're saying would there be a globe within a globe in that situation?
Yes, this is the most powerful, but control is very hard. It has a lot of problem. It has inherent problem. I built the very first one in Tehran about 5 years ago. And now we are in 3 and 4 layers reactors. We passed 2. But to produce such a system, you need a lot of knowledge and a lot of understanding of the fields and what gases you put in. Because in a 3-4 reactor combination, you create different layers of shielding. 2-3 core layers, rotating layers, used for defense of the system, for high speed and what we call protection, like in the cosmic dust. Mm-hmm. You use your reactor, the first 2 inner cores maintains your gravitational magnetic field. The 3rd and the 4th you control with your subsidiary reactors for shielding in the direction and strengthen. So what you do, you bring in your 3rd, which works in the outer boundary, and you use one of your 120-degree reactors to strengthen the shield in the direction of the motion. So you have two layers. This is part of the defense, and I'm sure Iranian governments use it in their space technology, especially for capture and landing. You have to maintain your gravitational, but you increase your dimension with your third and fourth reactor. This is very important when you travel into or you create variation magnetic field testing, that you can get away with the first shield, use a central core plasma. Central core plasma, very much like a sun. Then you have to know how to create different layers of magnetic field in your plasma core. You do it in a specific way through different material. Centralization does not just come with hydrogen or helium. In the body of the man is done by 4 different elements. In our amino acid. So if you learn that, you can convert it into practical reactors. But the glass tube you have there is very, very, very interesting. I've seen the guy is doing on the internet. He shows a plasma and he plays with it. This American guy has recently come on the scene.
The primer fields, I think that's called. Is that correct?
I don't know. I've seen one of his videos. It's a nonsense. He literally, when we were talking to you, it's like a globe you have in the back of your picture on your what do you call it? All he is doing, he's making a glorified version of this. Yeah, we use this in the labs in the physics in the secondary schools.
That's true.
So what is done, he creates what he calls a plasma, and he puts current to it. So it shows the light, or he says this is a plasma, and this is what it's doing with it. This is something that's been done in the 1950s.
It was done back in the 1910s and 20s, even with they were experimenting with the high voltage and showing that the effects of the galaxy are created by doing that. You know,
You don't need high voltage. You don't need high current. If you look at the video we put on our forum about our reactor, and if you look at the power supply, we use very, very little, very little.
You were using about 150 volts is the way I was reading it. Is that correct?
No, we don't. No, the system maximum uses, we use a 9-volt battery, rechargeable battery, to run the operation in testing.
Wow.
Okay.
You see, when you do a rechargeable battery, you connect your battery to your motor to start your running, and then you take the energy from your reactor once the plasma is created to recharge your battery, so you become supply independent. This is how you isolate from control from outside. If you have a power supply, you have a line connected going through your shielding, let's say, and you can't have that.
Right.
Simply look at the Columbus, the shuttle. When they come back and they come in the wrong angle, they give it burn. If you create a field, you have to control it internally, because the shielding will not allow you to go anywhere else. You become isolated, you become insulated. So we have chambers built internally. We have even gas chambers built internally for control and feed. You cannot work with a cable power supply. You have to build your power supply internally as part of your reactor.
Yes, we've been playing with that high voltage thing just to see different effects and see what happens with our, like we take a plasma ball, which when you hold it this way with this little column in the middle, it looks almost identical to your patent actually. I can actually hold the your patent up here, if you can see this, and I hold this right in front, and it matches exactly the patent.
Yes, but look at the drawings around it. There's a lot of information in that drawing.
You bet, yeah. But it's interesting that the gases inside this little plasma globe are inert gases, many of which are the same as in your reactor. So that's why we started I got the idea anyway, to start playing with a plasma ball just to learn more about it. What happens to a plasma ball when you put it in a vacuum? What happens when you spin it at 4,000 RPM? So we did those experiments, and
And what was your result?
well, when we spun it at
You
you can see the central tendril is forming there now, 1,000 or so RPM. So we have this plasma globe. It's got the gases inside, and we decided
what gases you have in?
Well, normally there's argon and possibly some neon and other gases along that same range, possibly some helium, depending on the colors in each particular plasma globe. Apparently, quite often they use argon and xenon.
This is something you bought off the shelf.
Yeah, you buy these for like $14, and it's got...
Yeah, I know. I thought you made it yourself.
It's got a high voltage power supply all ready to go. No, that's the thing about it. It's already made. In fact, I've already taken the bulb, the glass part, out of the bottom, and we put it inside of a vacuum chamber that I made here. You can see the bulb sitting inside there. And then we've run it with high voltage from an automobile coil system, 40, 50,000 volts and so on. And in fact, well, we could try it here right now, actually, just to show you what it looks like. You get a purple plasma happening inside the chamber, basically.
What color is it before?
Well, the ball itself will be like a normal... It's normally this color with tendrils that are blue and so on. We go ahead and turn the vacuum on there.
No, there's no the power thing. Okay.
Just a second here.
This is what you call a live performance?
Yes, that's right, exactly. We change things on the fly. Last week we probably changed the chamber 100 times and tried 100 experiments in a couple of hours. Do you want to get ready for that light there too? We'll do that. So this is on. Okay, I'm not sure if you can see that there. I might have to lift it up. It gets a little dangerous. Oops, we lost it there. Can you turn the power off? Yeah. Okay. Can you kill the kitchen light there, Paul? I don't know, can you see that at all? It's kind of dark.
It's bluish something.
Yeah, it's bluish and purplish inside there. We can actually move it a little closer if you're really careful. Up the wires up.
Rick,
Yeah.
Mr. Keshe cannot hear us.
I'm back. The minute you touch something, you got up even there.
Maybe it was some of the high voltage might have affected things. It's entirely possible. It'll kick out my cell phone when I get it too close.
Oh,
Okay, sure. We can try that again here. We're going to have to kill the big light.
Yeah, I will.
Okay.
Turn it on.
Yeah.
Ask if they can see anything.
Can you see anything there, or is it too dark?
It's too dark in the backup. Yeah, I see the plasma in the line now.
Yeah, it's just starting to sort of get going there now with as the pressure drops.
How come we don't have it with you?
I don't know. It's different this time. So, depending on some of the there's a different effect now than when it's at the very high vacuum. Just takes a little bit of vacuum that's less to create a totally different sort of phenomenon there. And right now that, pardon me?
Do you understand the reason behind it?
Well, I understand that the plasma changes with the pressure quite a bit in terms of the way
Well, you have a gas tube inside. The pressure has nothing to do with the pressure. When you vacuum the system, is literally you reduce the number of the elements inside, so you allow the plasma of a proton of what is inside the chamber to open up, so your plasma inside the light connects through to the energy or the magnetic field of the gas element which is outside it, which you remove. So in fact, it's a connection of magnetic fields that allows the different different shape of the plasma. The more you extract, it's just like a balloon, it opens up more. So the plasma is freer. This is how you generate electricity or power. When you create a vacuum, you allow one or two, or let's say a very limited number of plasmas or atoms in, you strip it, now you play with the game. This is a very nice way to show the opening of a plasma. Here, in a normal condition, when you're not a plasma, it's like having 20, 30 blankets on top of you.
exactly.
As you take the blankets away, the plasmas which are left in there is no full vacuum state in the universe.
Right.
Vacuum is a wrong word in the vocabulary. There is nowhere in the universe which some magnetic fields are not traveling through it.
And even having hydrogen atoms and so on in every square or every cubic centimeter. There's a few.
That single, if you have a single atom in a cubic meter, that plasma will cover the whole cubic meter. Yeah. So when you create,
this is a hard concept to get your heads around. But I've run across this. I understand what you mean, but it's a big one.
it is exactly like a gas.
Yeah.
The behavior of plasma is exactly like a gas. It fills its container. You understand?
Yes, definitely.
So when you take so many atoms out of your cylinder, you allow the very few plasmas which are outside the tube to open up. And in opening up, you allow the energy transfer across. In fact, I usually explain this kind of things is like you have a solar system inside, and you create another vacuum solar system outside, and the solar systems interact with each other. And that's even how we see the color of the Earth or the color of the solar systems. It does not come so much of the production of the material. This is coming up in the book number 4. I've explained it in a very detail. Even what they say, what you see there as a blue color, it's a wrong conception that we say the sky is blue because of the color of the water, or the water is because of the color of the sky. The color of the Earth or any other planet comes from the interaction of the magnetic gravitational field of the internal matter, which is Earth inside the pores, and gravitational magnetic field of the gases which are around it. You understand? Mm-hmm. So even the strength of the shine of the, let's say, the star, it depends on the plasma strength on the top layer, which interacts with the gravitational magnetic field of the plasma internally. So It's exactly the same as when the light of the gravitational magnetic field of the Earth hits the gravitational magnetic field of the Sun. We have a daylight. That's the interaction. This is when you run your reactors in a space level, the gravitational magnetic field of your system with the Earth creates a light around your reactor, around your craft. This way you create it in reverse. By vacuuming, you take layers off. Now the plasmas can interact. So in interacting, your plasma inside your tube opens up to the external tube. Opens up, so it has a time to interact with what you have inside, and you see the change of the shape. In reality, it's still there, but now you allow different combination of interaction of the fields of the few plasmas you leave inside. You see this if you change your gases or mixture of gases, then you see different colors, and that's why we see different planets in different colors, different stars in different strength. We are showing physicality what we see in the universe now for the first time. We can explain it scientifically.
Yes, that's right. We want to experiment with some different gases, even with our crude setup here, just to see the different colors that come out of it, so we have some understanding about that and how that works. It's we realize that high voltage is not the way to go with your reactor, but at the same time, it's a good experience and a good education to play with it a little bit, just to see what happens with voltage in a vacuum chamber, and it's quite amazing. It's been an eye-opener for me to just be able to see that.
This is what that guy shows, and everybody thinks is magic. But what it does,
we could do the same thing in this chamber very easily. It's not.
It's very interesting. If I show you something to do, run your reactor again, run the same chamber again, and put some magnets around your chamber opposite each other.
We already have a magnet underneath here. Ring magnet is actually in the bottom of the chamber.
Put your ring magnet on the side, and you see the shape and how you can change gravitational field on it. It'll be very interesting if you can see it.
That we experienced that like a couple of weeks ago.
Yeah, we've had some experience with that, with putting magnets on and changing magnets and so on. And I also have, I've got this arrangement here too, which is kind of handy, which is it's a motor. It's a Subaru blower motor from a car, a heater motor. But I've got 6 neodymium magnets in a flywheel here it's mounted onto it. And we can put that right on the top of the reactor and create magnetic fields in the reactor, and actually have a magnetic drive on the other side of the polycarbonate. So I'm able to drive magnetically the plasma ball, for example. So we are playing with magnetic fields, but a lot of times I find that the magnetism isn't affecting the plasma really. Like when we take the plasma ball like this one, and we hold a magnet up to it, while my hand will make more of an influence, will have more of an effect on the plasma than a magnet will generally.
Can you show it? I'm going to explain to you why.
Okay. Here's a big honking neodymium magnet here, for example. And when we put it up to here, it doesn't...
Kill the light. Okay.
Yeah. Put the finger next to it and see the difference between the two. Yeah, okay, and do the other one. This exactly shows what I was explaining to you. The solid magnet has property of much denser electrons, so you don't get it.
Could you explain that again in a different way, please? What do you mean it does?
When you have his finger on, there are a few different factors where you don't have with a solid magnet. First of all, the body is a current generator because you have a blood, which is a magnetic flow itself, and the shape of the flow, if you look, is very much near to his heartbeat. If you see it,
Well, it seems that way.
Yes, I do.
It's,
this is the current flow of one with another. You understand? So the shape is fixed, its pattern is fixed, because the body of a man is a lighter gas composition. But the blood flow creates its own current, so it affects the shape of the plasma with the center. You use these kind of effects for targeting destination in the space technology. These are applications. You see now, you have all those. When you put a finger, you collect them together, and the shape is fixed with a heartbeat.
Oh, fixed with the heartbeat.
Yeah. Well, I thought it was more of the convection currents going in there. But
your body creates its own, but your tissue is softer. So your plasma is easier to create with it. Your hard material, like the magnet, you see you concentrate everything in one position. You don't get any more than what's in there, but you bring it together. Where with the solid magnet, you don't have that property, because it's compact. It's the same as you create vacuum or lighter material.
Right.
The non-vacuum condition is a metal, which is heavy compact, there is not much room. When you put your softer material, which is your tissue, which is a combination of lighter elements, then you have a better condition.
Yeah, we talked about that earlier today, he and I think, and I gave the example of the atoms like to have elbow room. They like to room. Right, and the hydrogen atoms are there. Whoa, we got elbow room. This is great. And then you have a magnetic field as well, and they all line up, and they're real happy to let go of their electrons at that point.
Yeah, but what is interesting, which sometimes I look at it and I understand it, but it, in a way, to understand the reality behind it is different. You have this glass container, which you're creating the original plasma in. Why does the change of the plasma outside it in your second chamber affects the pattern of the plasma inside that chamber?
Exactly. And there's times when we've gotten a really good flow going with it, so that you could see the outer flow flowing around and swirling around the inner globe, and then the flow inside the globe is a separate magnetic field inside there, a whole separate field that was activated from the flow of the outside field.
Yeah, so this is, in fact, it shows fields in a plasma level in so many ways have no boundaries. They don't understand separation.
That's right. Well, that's something we learned too when our hose started lighting up that goes to the vacuum pump.
Which hose? The vacuum pump hose?
The vacuum pump hose. We had that.
Yes. Be careful. What you do, this is what I usually do, put a magnet ring on that pipe. Build a unit that you cross your magnet to your pipe through it. Right.
And that will take out the plasma, the harmful plasma, is that correct?
Yes, but the thing is, it can that flow can go in the motor and burn your motor out.
I wondered about that because it didn't look like a good thing to have 2 feet of green hose happening.
You don't see the whole pipe lining up, and the length of it does.
That's right, a couple of feet, and if you were to touch it, it would light it up stronger. It makes it brighter.
It's the same as your finger you just showed. The best thing to do on that pipe, somewhere on that pipe, close to your reactor or away from it, you use a very strong magnet that you pass the pipe through with a ring magnet.
I see.
Around the pipe.
Yeah.
You can't find it.
We did try putting a magnet up close to the pipe, like squishing it a little bit with the magnet, and it seemed to sort of amplify it a little bit even.
You have to use a ring magnet.
Right.
If you can find a ring magnet, are you using a 4 or 6 millimeter pipe? It looks like a 6 millimeter pipe.
This would be 6 millimeter, yeah.
Yeah. Use a 6 millimeter ring that is actually, you pull it through it very strong, that there's a contact all the time, so you stop the flow of a magnet. But sometimes if it's too strong, it still jumps, but you freeze it. It's a specific way to do it.
So is it a good idea to have another compartment?
No, it's just a ring. Just put it through it.
Right. Well, you did mention the idea of another chamber to be like a dump chamber, to let the plasma settle down in.
The way I do it. This is you see what happened in the vacuum when you go for actual testing and you put gasoline. If you release the energy which is in there into your pump, you burn your pump out. Yeah? You are now working with a real vacuum plasma condition. When you work with a real plasma condition and you're in a dynamic, you open the what you call the transition levels. You never get to the principal level. You open the higher order of transition level. By the time the transition level comes to find its new parameter, it releases a lot of energy, a lot of magnetic field beyond it to find its balance. And then this surplus magnetic field, the gravitational field, when you suck it out, it goes into your pump, and you find all the plastics in your pump become like the chewing gum.
Oh yeah. Now would that go for our kind of pump that we have here, which is your standard sort of refrigeration unit? This is what we have to operate with.
I use that. I use the same kind of pumps. But the best thing is to connect this pipe into a 5-liter cylinder, probably not stainless steel, but a steel container, a cylinder, yeah?
As opposed to, I've got an aluminum, what do you call it, pressure cooker I picked up here. I was hoping to modify that to use that.
You buy this about $50, $60, these cylinders.
Mine was $5 at the Salvation Army. That's where I get all my good things. It's surprising. I walked through the Salvation Army looking for plasma reactor parts, you know.
I've done that as well, don't worry.
I spent an hour, the Lady Dragon knows, she called me, I was at the refrigeration supply place yesterday, and we talked for about an hour while I was wandering around there looking at all the neat things, like I was lusting after a vacuum gauge that cost about $300, for example.
Yeah, well the thing is, this is what I do in my writings that I always explain. There is enough material around the world that even in Africa, if people look into second-hand shops in the scrapyard, they can make these systems for themselves.
Very cheap.
That's right. That's really encouraging. And you know what changed my life a few months ago is when I heard you say something about that there will be people making these reactors in their garages. And that, to me, that's, you know, kind of what I do. I'm an inventor and mechanic and so on. That's what I've always done. So that was so invigorating and so much of a grand idea to me that it might be that simple, you know, that it isn't really rocket science. It's actually simpler than rocket science, but it's still very exact.
Rocket science belongs to NASA. The spaceship program belongs to the people in their homes.
That's right, exactly.
I got a quick question.
Yes.
Okay, I will turn on the video for a moment. This, I don't know if you can see it. No, it's not better.
Yeah.
This is a container from balloon gas. I have one pipe going to the bottom, and the other pipe is going to the same top. And I was planning to fill it with water in order to discharge the reactor inside.
No. Don't use any liquid. because the wafer goes back into the reactor, it causes all sorts of problem with you. Once you extract the gases from your core, the minute it hits the wall of the cylinder as you have, it releases its energy into it, that's it. But it has an advantage when you use a cylinder like the one you have. Whenever you want to create vacuum, you go and install the pump. In your case, Rick, you have to turn the pump on every time you want to create a vacuum.
Right.
With a double chamber, even if it's to outside, you always have vacuum as a reservoir. You just open it and it's there. You don't need to use your vacuum pump. Especially when you use a molecular vacuum pump, these are timed because they can get damaged. Molecular vacuum pumps very easy, and they usually have a timer on them how much you've used them. So by keeping a reservoir of vacuum, or two reservoirs, one for discharge and one for charging, you always have a reservoir ready, and you don't put so much pressure on your pumps.
Right. The turbo, the way I understand it, the turbo molecular pump, it can't take regular atmospheric pressure. It has to have a roughing pump, or similar to what I have here, in order to bring it down to vacuum first, and then you use the turbo molecular.
Turbo molecular always next to a rough pump together.
Right.
The rough pump comes on, takes you to -1 or whatever, and then or -2 or 3, and then the molecular comes in to take the last bits out.
Right.
Even when we use the molecular pumps and you think you still have a total vacuum, in the chamber there are millions of atoms still left behind, gases.
I understand that the hydrogen and helium, the lighter gases, are the hardest to get out. They tend to stick around in there.
Use them. You don't need to get rid of them. You can use them.
That's what I was thinking, yes. They would be what remains.
Yeah. What you do is you try to unify the atoms in your container. What this means is, instead of having, when you do the first vacuum, you pull out a lot of things. It's all helium, nitrogen, whatever, CO2 in the cylinder. But there's still some of them left. What I always do before I start the test, I feed in 3 or 4 times hydrogen. When you feed in hydrogen, you reduce, then you vacuum it. Then you put hydrogen in second time and you vacuum it. And then you do it, you reduce you minimize the contamination of any other atom. But if, for example, you're using plastic or glass, even metals, certain condition of the vacuum releases part of the material which is in the construction, in the structure. So contamination through the wall of your core is a natural process. So you have to build up this layering, that you push heavy materials or heavy gases or any change of composition in the structure of your reactor not to come in touch with the plasma. You understand what I'm talking about?
Now, is part of that, the way I understand it is having a copper reactor helps with that a lot, because of the, when the magnetic field of the plasma gets close to the wall of the copper reactor, it will tend to repel because of the induction, magnetic induction forces involved.
We have plastic reactors.
So does the plastic repel the plasma, or is it just the combination of gases inside that are correct for an insulator?
You use the gases as a shielding, as a containment. You have a solid containment of the plastic. One of the best things to use is carbon. If you can get carbon gas.
Carbon gas, yeah?
Yeah, but the carbon is very It's a specifically some places it's very easy to get. Yeah.
I haven't heard of carbon gas. That's an interesting idea.
I produce it myself.
Okay.
This is the structure of you work with a CO2 as you buy to carbonate the drinks.
Yeah. Yeah.
Through a specific process, you separate your carbon. And there is another method which I show on the internet, quite a lot of people don't understand, is through the Coca-Cola bottle. That's the easiest way to do. Then you use your carbon for, what do you call it?
So
It behaves as a conductor and a resistor at the same time. Depends what vacuum condition you put on your central core. CO2.
Now this wouldn't work with straight CO2 or with I have welding gas for my MIG welder, which is CO2 plus argon.
Yeah, and you can use that. We've done that, but the thing is, if you use CO2,
then you end up with O2 in
you have a
there.
hydrogen, you get a moisture in your reactor. You get
Right.
a natural flow of moisture. And then if you get to the positions, you find out a lot of your valves externally between the core and the pump, they start rusting internally.
Oh yeah.
This is somewhere where the condensation becomes vacuum to water. It took me a long time to discover why I'm losing my valves.
Huh. Wow.
Because you create a condition of a rust very quickly in those positions. So these are little things you learn by experience, and you try to find out why you get to these positions, because you run your vacuum pump and you don't get to vacuum.
Yes, well, last week we discovered about using water. We put water in our vacuum chamber and high voltage just to see what would happen there. And the vacuum pump oil got contaminated really quickly. It's got all foggy and sort of yucky looking. So I changed it, had to change the oil in the vacuum pump.
It oxidizes because it takes in the moisture from the oxygen from the water.
Right.
You have to keep away all the time from combination gases which can combine to give you new matters. This, in some cases, you deliberately create the condition to create material.
Right. So what would some gases be that would be true contaminants? Like would oxygen be an obvious one that would tend to...
You don't touch oxygen.
You wouldn't want to have, even the CO2 part of the CO2 wouldn't be a good idea probably.
These are the things you have to learn by experience. And if you always, I do this all the time, when the last barrier before your vacuum pump has to be microfilters, that they stop any new material built in your reactor, any moisture to be absorbed. Yeah? So these things get created in even in the pipe. If you understand the structure, you can allow in part of your pipe, while you're running your tests, to create protein. You know the glow you saw in your pipe? Yeah?
The what in the pipe?
You said you could see glow
Yes,
in your
right.
with the pipe between the vacuum and the chamber.
Yeah.
You can create conditions around your reactor that in different sections you produce different materials. Huh? So you produce liquid, you produce matter. And if you can feed in part of your pipe the specific condition gases, you can produce protein. This is what we done in Tehran, yeah? Because we understood, we understand the structure. But now scientists like you have to test to come up with different ways of doing it. The way I say in my pattern, I cover every aspect of it. The way you see you do your reactor or Ludmil does his reactor different way, There are as many different types of creating the same effect as there are stars in the universe.
That's a great way to put it.
You understand? So not only my way is the correct way. The way I explain it is a general way to approach and to reach. So if you change it slightly, you get the earth condition, you get water. If you change it a slightly different way, you get liquid something else, or you get gold. This is what we try to explain in deep space. We don't build different reactors for producing different materials. We use different positions of the reactor to produce different materials. This is a misconception which I see a lot of people do when they read my patent. So if you want energy of the protein, you go closer to your core. You want less, you go further out. And that energy is always there. Energy is magnetic field in motion. You have to decide in your reactor in what strength you want to be, and then you calibrate your reactor core that this position gives me protein level. This level gives me copper core. And then when you can tap into it, when you extract it, it gives you different material. Material production in the universe is that way. So if you got the sun in the center, that's your middle core which you just turned on. As you go further away from the core, the strength reduces. When the strength reduces, then becomes weak enough that it becomes matter, and then you different type of matter. And depends where you are in this matter, you get liquid, you call it Earth. You get a harder, you get Mercury, and then you get Jupiter. And because of their position and the gravitational field, they position themselves and they absorb that material in there. So you become a sponge for that material. You understand? This is what we call, you can create the gravitational magnetic field of any element. So you don't need different reactors. You have the way you showed there, the way your plasma moves, the way you touch your finger and you see the field come together. You understand? Once you have energy of one matter, then you convert that energy, which is a magnetic field in motion, into a gas and a GANS. And then there is a process to convert the GANS into matter. You understand?
Yes.
So
right.
basically, just to try to understand that, let's say Rick got 5 meters pipe. In the first meter of the pipe, when glows, you will get 1 meter. In the second meter of the pipe.
If you create the right condition, yes.
Yeah, okay, yeah, that makes sense.
It's like condensing out the materials from a higher energy level.
You see, the misunderstanding in the world of science, a lot of it comes from biology. Yeah? The man never understood the biology of his own body, and he's taken the same mistake into the universal condition. So, if you understand this, that's why I say you treat the body like a galaxy, then you understand what everything is in the galaxy. In the galaxy you have all the matters of the universe. So the condition is created to create that matter in that position. You have to understand how that condition is created. You create a condition which only gives you protein in the pipe. You can create a condition in the pipe where you only produce gold, because you need gold. You produce a condition which all the fields come to the strength of, let's say aluminium. You don't need to take aluminium from earth or do a conversion. Conversion of a matter is the habit of man. Universe converts as it needs. You have to understand what the need and the position is. In certain gravitational fields, aluminium cannot exist and hold the way it performs on Earth. You have to find a matter which holds and performs as aluminium the way you want it. Aluminium, most probably in other surfaces in the universe, just becomes evaporated, or becomes so solid you can't even cut it. It's a conditional, environmental conditional dependence. It's the same as what you did in that tube. As you change the vacuum, different plasma conditions showed itself. This is what we as humans always related our science to our own body, and we never understood it fully, so the mistake has piled up.
Well, I found it quite interesting. I was doing the work to translate one of your latest videos to the English, to write the English out, and you were talking about our bodies having radioactive substances in them, and that they're there for a very definite purpose, and that is having to do with this cutting action between the cells and so on. And I thought that was a really good idea that you brought up there, and something that I hadn't really considered before.
The thing is, in the universe, there is a cutting mechanism. The cutting mechanism comes very simply at one higher level. Yeah? You want to cut, in the matter world, you want to cut a bread, you can cut it with a piece of a string. You want to cut a bone, or you want to cut a meat, you use a knife. You want to cut a bone, you use a rotating steel. Yeah? When we want to cut diamond, we use diamond, which is in different shape. Yeah? So, the same principle applies in the universe. You use radiation because they are thinner, they can cut through. The thinner the deviation or division comes through a lighter radioactive material, and stronger, like bones and heavier material, it goes through the heavier. Cesium, we use it. And it's the same process in the body. You use B12, you use B6, you use B9. So you have to create a condition in your pipe for what material you want to produce. In reality, you dictate. In Tehran in 2008, I knew I'm going to produce protein. But the effectiveness which was produced, in a way, puzzled me. How easy it was to produce it on a continuous basis. Because then I realized you create a condition of a blood vessel. The blood vessel, the structure of the blood vessel is a converter of energy into matter. This is why no, what do you call it? No iron crosses the blood and it goes and finds itself in the cell. The energy of iron, magnetic gravitational field of an iron package, transfers through the blood vessel, and then it changes the gas into matter, and it becomes gas. This is exactly how we produce CO2 as a solid state. So you produce the same thing through transition of walls, different strength. And this is what in book number 5, I explained this very, very thoroughly. And even in the presentation of in the center a few months ago, where we speak about lung and blood, I explained this. Soon we're going to release the video of it. I explain how no oxygen ever crosses the wall of the lung. This is a myth. This is like saying the Earth was the center of the universe. No oxygen ever crosses the boundary and the lining of the lung. All it happens is, it's in the video and it's in the book coming out. All it happens, that's why you get a CO2. You breathe in oxygen through the same thing as you're doing in that tube, and the material which is within the lung. You take only oxygen is 16, carbon is 12. You only take a helium factor out energy level, and that energy transfers across the boundary of the wall of the lung into the blood. And no oxygen goes into the blood. All it does, this energy energizes the blood, what we call red blood cells, and they become brighter, exactly like the way you do the light toning. You increase the energy, the light becomes brighter. This is a misconception and total misunderstanding of modern medicine. There is no oxygen crossing your lung. And then what happened, because you take a factor of 4 out of the helium out of the oxygen, what are you left with carbon? The carbon binds with 2 oxygen, which is coming in, you breathe out CO2. Because that's the stability of the magnetic field of the package. So no oxygen ever goes through the wall, because this is nonsense. The molecule, the atom of oxygen is so big. When you breathe in, you breathe carbon, you breathe nitrogen, you breathe hydrogen, you breathe anything else like the elements. So if a molecule or an atom of hydrogen is supposed to cross the wall of the lung, all those lighter gases are smaller, they go through too.
Right.
So we don't see that. Our body has, in our blood, has a specific gravitational magnetic field for helium.
Right.
Yeah?
See.
And it extracts that much energy out of the pack. It's just like you bring a pot of water, you bring a bowl of water, and you just take a cup out of it, what you need, not the whole lot. And this is another misconception. And if you understand this and then convert it into your pipe with shine, then you understand how you can create different matters in the space. You don't need to take anything with you.
Mm-hmm. Yeah, that makes sense. I mean, otherwise we should have more nitrogen in our blood than anything else, because the air is 3/4 nitrogen, right?
Yes, but what is the nitrogen? What's the atomic number of nitrogen?
I think is it 14?
What's the atomic number of oxygen?
Be 16, correct?
So how can the smaller one go this top? And even go for a carbon, go for a hydrogen. Yeah? Even if you go for a molecule of hydrogen, which is in the air we breathe, that should be able to get through the wall of the lung very easier than the hydrogen, than the oxygen. So no oxygen ever crosses the wall of the lung. No element ever crosses the wall of the blood vessels. Is the conversion packages. The minute we open the blood and we test it, the conversion comes. That's why always there's a calcium in the blood, there is a blah blah in the blood, or there is a zinc in the blood, because it's a balloon of a plasma equal to copper. When you open the blood, the minute it comes to the atmosphere touch, it changes to matter. You understand? So if you go into the blood vessel, we don't see any red blood. It's colorless. The minute it comes in touch with the body, with the air, we see the color of red. So if you have a different composition, when your blood comes in touch with the air, it becomes blue, yellow, whatever, or green. This one you understand? This is causing a lot of thinking, and what I'm writing now. Why we have different blood colors? Why should we green or blue? We have animals which have a blue blood in the sea, and it's used by FDA for faster testing of the new pharmaceutical products. Yeah, there's like I can't remember his name. It's got a blue blood, so for FDA now it speeds up the testing time for new medicine using this animal. It's a fish. It's like I can't remember his name. So because different material, because that blood has copper in it, it's blue.
Oh yeah.
Ours has iron in it. We are red when it comes into interaction with the air. So when we see other creatures in the world, in the universe, which have a different composition, like potassium or calcium or whatever else, we see them different color blood. That doesn't mean anything. But the other thing interesting is, would we be able to interact and produce offspring of each other? Because when one is the stronger, can destroy the other one. So most probably we can never have children with aliens, huh? Or not with some of them, because the blood is different than ours. You understand?
Yeah.
So these are the things you see when you run your reactors. These are the things you You should watch when you see a glow on your pipe the way you did. Try to analyze it outside the box in reality, not the way we've been forced to understand. Understand the behavior of the plasma, understand the behavior of the universe. They're all the same in different scales.
Yes, exactly.
So basically, going back to transferring energy in the lungs, does that mean if you can create a reactor and condition, which is with the same energy like oxygen, you can use it without using the lungs?
Yes, that's what we do with our patients in the medical section.
Oh, that sounds great.
This is why when we have a COPD patient, we give them a pump that does not deliver oxygen. It creates and delivers the information of the conversion of helium in the lung. So in fact, the lung goes on the rest condition, and you just transfer helium energy plasma across the wall with the information. And this time of repair allows the lung to repair itself because it's not used for its function. This is one of the problems we see with COPD. COPD people, I have had a COPD guy who comes in, he can't walk for not even, when he walked on the table, we had to wait about 10-15 minutes before he could say the first word. And then a few months later, he came back and he sat and he stopped talking and says, "You've done nothing for me. I still have my COPD." I said, "Guy, because you know in the foundation you pay if you like." He says, "I don't want to pay because I haven't seen any difference." And I said to myself, "I have a video of this stupid man. You came in 3 months ago. It took you 12 minutes, 15 minutes before you could even say the first word. Now you come in and you sit and you see no difference."
Now his first word is to complain.
Yeah, no, it's a cheat. It's a habit of the man.
Yeah.
But I see a lot of people come in and they say nothing has changed, and then when the husband is not there, everything is changed. Because in front of the husband, they cannot be good, otherwise they have to do more at home. So we see this behavior, but we use these pumps to allow the information of the plasma of a helium to transfer across the lung. So the body does not need to be used for the conversion. So they do that very much like in the new heart operations. They don't take the heart out. They put a second heart next to the body for 12 months or so, which takes the pressure of the original of the human heart. And in that time, the heart gets time to repair itself, and they take the pump away afterwards. So, you know, these are the new, we see it now in practice in the same thing, but all these starts with the same as your pump, what you have there. You see the glow, understand why the glow. And this glow, as you see, the further it goes near to your vacuum pump, the color changes, becomes less and less. It's stronger near your cylinder. So it means there are different matters, because different magnetic gravitational field plasma create different brightness. So you already seen it, but you never understood it. So if you want copper, go near there, create a condition in that place. If you put a rod in, you can continuously vacuum copper out. Cool. If you go further away, you want oxygen all the time, you continuously at that point convert oxygen. This is why in the universe, or let's say in our solar system, we see cosmic dust in the boundaries and from the Earth and before Earth up. We don't see that much cosmic dust near the sun because the materials haven't lost enough of their matter energy to become matter level. And then as they become different level, different strength, you see the cosmic dust is the wrong word. It's the solar dust. Because these are the conversion of the energy magnetic field of the sun, which as they lose their strength, they become matter in different positions. So cosmic dust is a wrong word. It doesn't exist. In the same way, in your system, you create different materials. You see different lights means different magnetic fields, gravitational fields. You tap into it, you have what you like. You want gold? How many kilos? You understand?
Exactly.
So this is the process of not creating energy, creating motion, but creating matter in the energy level that we don't need to use consume food in space.
Right.
You're in a very nice track. You're doing very nice job. But these are I did this about 30 years ago. So
Yes, exactly. Well, we're on the fast track, but we're trying also to go one step at a time and to try to understand what's going on as we move along. So I mean, we start with a simple plasma ball, and that sort of gives us an idea of what that world is about a little bit. So, and now every week we progress quite quickly, I think, and we're doing better all the time.
where are you now? Can I see your latest reactor if you want to show us?
Well, I don't have an actual reactor at this point, except we have we have a little setup here, for example, with polycarbonate glass and a vacuum chamber, and it has what do you call it? The
Electrodes.
yeah, electrodes on here that we can put high voltage into and get another effect out of this little setup, you might say. We've also have quite a nice chamber here that we can also use as it's a glass chamber, heavy. It's made for a lighting system, but it will be a good vacuum chamber to use, or at least an outer chamber to have a globe, say a rotating globe on the inside. Basically, the vacuum chamber that I built, the larger one here, I look at it as more of an outer container for an inner system. Like, I could see possibly using an actual plasma ball as a globe system, and I can grind off the little nib on the bottom and put a hose on and suck the air out of this, and then put in the mixture that we wish to use in it. So that you see as a possibility. We've already been able to spin this up to 4,000 RPM, and we observe the changes inside the globe. The tendrils tend to change. The one tendril will go straight to, and at one certain point, right about now, the tendril from the center of the globe goes straight up to the top of the globe. The top here.
How do you feed it?
Well, we've done it a couple of different ways. One is with its actual little high voltage power supply, and
Has batteries.
it has four AAA batteries in it, and it just slips on top of the globe that way, because the globe has a sort of a
Tube.
finger inside, you might say, that that this part can go into, you know.
Yeah, and then you put this one on that rotating magnet.
We can. Look at the beam, yeah, it's quite amazing.
It's like it pop up all the time.
Wow, yeah. And put this in. We put this into the vacuum chamber and tried it just plain, and then oh, there it goes. We determined that it made the globe go out, and then eventually we figured out that it was the shorting out in the high voltage transformer here as part of the chart. You know, part of the high voltage system. It was just arcing over and causing this blue glow over the whole circuitry here, essentially. And that's what happens at the low vacuum condition. So then we took this part and put it outside of our vacuum chamber and just ran a wire in to run the globe. So we mounted the electronics onto the bottom of the vacuum chamber. Plug her in. Nice. And we tried it that way. And then we've also run the globe with the high voltage from our car transformer or car coil setup. So we've tried different ways to fire it.
Ask him what we can do next.
You don't need to ask him to ask me. Ask it yourself.
Hi there.
Hey, this is Paul.
I recently immigrated from Holland. Now living in Canada.
Man,
Yeah,
Dutchman.
it's too busy in Holland.
Ask your question. Ask your question.
Okay.
Yeah, what kind of experiment we can do to make any progress towards the Keshe technology? Because right now we're just playing a bit with electricity and vacuum, but it would be cool to have some direction.
I'm pretty sure if you use the globe you showed me,
Yes.
and you understand the way you created the vacuum and in the secondary cylinder with your vacuum pump,
Yeah.
change the characteristics of plasma.
Yes.
With a simple like that, you can create enough energy to run your lab.
Sounds good.
Well, that's a big hint.
That is a very. You see, I have a habit. I don't teach nobody nothing, but I tell you what it can be done. Because if I do, that's one of the reasons we don't put our systems out so much. Because then the people think, oh, that's it, we copy that. This way we allow thoughts and different ways to come out. It doesn't become a photocopying machine. So, in fact, with what you have there, if you can put an electrode, you can maintain your plasma, and you put an electrode, not even electrode, you can create a condition that you can absorb the energy of the plasma. I think in that chamber you can produce enough energy to run your house for about 20, 30 years.
Right, sounds good. But
Now, what would be the activating factor? Like normally, I've seen in the patent, for example, there'll be radon gas in the outer part of, like they say, we had the globe inside the. You've got your.
Hello, stop.
Okay.
Go back to understanding the property of matter. Yeah. In a chamber, when you put argon, it does not stay argon. Yeah. A gamma ray does not stay gamma ray. Gamma ray stays in the gamma ray as long as it has the strength of what we call gamma ray. Then become different rays. Yeah? These names has caused the biggest confusion. Use them as a strength level, not as a matter level or energy level. Yeah? So if you use argon, what is argon? What is atomic structure? What is gravitational magnetic field structure? You create a condition that it reduces or releases most of its matter faster or slower. You understand? So if you put argon in, you can use the inner layers of argon to release gamma for you, or beta for you, or X-ray, or soft X-ray, or even create matter. You have to understand walk away from matter and work in the plasma, and then the simplest way is think of the solar system and move away from the sun, and you see what things you get. I think book number 4, when it's released, hopefully next couple of months, a lot of people will put the whole package together. If you read book, you see book number 1 was to explain the structure of matter, to put it the correct way. Book number 2 was the structure of the light. It wasn't to talk about the light. It's to carry the information how matters move in the universe. If you are a ball and you want to go to fly in the environment, you have a big resistance. You have a bigger surface ahead of you. So when you narrow yourself, you become a ray, what we call a light. It's easier to go faster. So book number 1 was about the structure, understanding correctly. Book number 2 was about the movement of this thing, Book number 3 was the collection of these things how behave. Book number 4 shows conversion of these things into matter, what we call a solar system. Solar systems are matter conversion systems. Solar systems behave like a blood vessel, convert energy into matter. You understand? So go into understanding the structure of the plasma, not matter. Then you understand you want different layers of, let's say, centralization through radiation. You can get centralization with argon, you can get it with helium, you can get it with nitrogen. In the body of man, centralization is done by nitrogen, not by anything else. You don't have argon in your blood. Yeah? In the upper atmosphere on Earth, the centralization conversion is done by nitrogen. In different parts of the universe, it's done by argon and heavier because of the condition in the environment where they are. The closer you get to the center point, to what we call a black hole, what we call a principal matter, the stronger knife you need to cut. So, in your little tube in the back, you can produce as much energy as you like. You want to be warmer, you move closer to the sun. You want to be cooler, you move to the Saturn. You understand? So you have to find a position in respect to your center. With putting that ball in the middle, you dictate the center. You dictate the position of the center. When you have that core in the middle, and then you create a vacuum outside it, you have already fixed the position of the center. Now move in your outer chamber where you want to be. You understand?
Dr. Keshe, can I put my nose in for a minute?
Yes.
If we apply a magnetic field inside the tube, inside the plasma, would it affect it in a positive way, or?
Depends what you put in there, how you create it. You want to add to it or you want to withdraw from it. You understand? It depends what you want to do. By the way you've done your structure is fantastic. It's beautiful what you've done. The way you show it with the outer chamber you built, with putting that plasma in the middle, you already have dictated the sun.
Right.
You have the position of the sun. Yeah?
Exactly.
With your second chamber, you decide you want to be on the Earth position or you want to be on the Saturn. You want to be warmer, you come to the Earth. You want to take more energy out, you come to the Earth position. You want to take less energy out, you want 100 kilowatts, you come to the Earth position. You go near your plasma. The 10 watts, you go to Saturn position. You want a few micron, you go further out than in Pluto sector. This is the easiest way to convert it. The closer you come to this point, with putting that core in the middle, you have already fixed the position of the plasma. All the plasmas respond to that position, unless they are stronger, which then that plasma responds to them. You can make a stronger plasma outside, but you have to reposition it. This is what we call 360 rotation speed. In the space industry, in the spaceship program, what we call it's in my papers on the net. You use 120 degree separation reactors. So you want to increase the direction of motion. You don't have a jet propulsion to go in that direction, In the space technology, when you want to move like the Iranian spaceship program, you see them flying with a high speed. They use a specific combination of reactors. You want to create energy from certain point, you bring the magnetic field in that position. You understand? So you do the same thing in your reactor. It's one concept, it's one principle. It's the application which changes it. You understand?
Yes, thank you, yes.
Okay, so
you have to, sorry about that. So in what you have on the table, to me, you have a 30 kilowatt system, maybe 50 kilowatt system. You understand?
Yeah, that's what I'm shooting for, basically, yeah.
So it depends how close you want to be. When we get close to the sun, we burn. Why? Because there is a stronger magnetic gravitational field, which our body gets dissolved into it. Huh? When you go further out, it's cooler because the fields have already lost some of their strength to the other fields in the area. Yeah? And then you have to understand the position of the gravity you create in your central core. Gravitational magnetic field in the center core decides where the matter happens. If the sun had a stronger gravitational magnetic field, the matter of Earth most probably would have been in Jupiter level or Saturn. Yeah? But because it has such a gravitational magnetic, the Earth matter conversion is at the position where it is now. You have the same thing in there. That's what I say, a farmer, a man in a village in Africa should be able to produce food energy from a simple system. If he goes in a car graveyard, everything which to produce energy is in a car graveyard. And the cars are everywhere. If you have a mobile phone, use the component of the mobile phone, you can create as much energy as you like. Understand the structure, and then the application is the same.
We did have an idea to take with a plasma ball, put a cell phone, tape it onto each side and see what happened there, because you did mention something about cell phones and...
yeah, but as soon as you touch it, you create transfer of matter energy. You have to keep it away. We did a test. I had a knock on the door. They said, excuse me, do you mind shutting your system? The whole building has run out of, nobody can get through the communication line. No, but I'm talking a building 5-story high, 6-story high, all concrete, about 100-meter circumference, easy, maybe more. With running a system of less than 10 centimeter, we could block the whole communication line. This is how I wrote in there that, the people came to knock on the door, says, can you close the thing down in your lab because nobody can talk in the building anymore. We realized the strength of it.
Yes, right.
All you do, you create a dynamic field which everything stays inside. Fields don't gravitate out. They cannot move out. And whatever comes out from outside. This is how the satellite was captured, how the American plane was captured. You literally, the system is the size of a smaller than a ping pong ball, you can make it. Yeah? But it creates such a dynamism that it doesn't block communication. It's centralized. It's like a centrifuge, holds all the fields internally. So nothing can go because it's stronger. You do the same thing with your system. It's not a jamming system, but you need this in deep space for specific uses. Where you want to absorb energy, when you run out of food, you want to absorb energy, you can't wait till you are near a sun. You create in your reactor condition that all the smallest field gets absorbed and you get attracted and you produce what you like from it. It's a process of understanding. In the system you have there, you can produce as much energy for the rest of your life if you know how to tap into it. You have a power generator on the table.
Right. Well, that's our work, is to unlock those secrets, and appreciate your input on that.
No, it's no secret. Look at the structure of the universe. Yeah? We know it all. We deny the knowledge to ourselves. We have it all within us. It's just, that's what I said, peer reviewing. These people who peer review it for their own pocket put that mindset on us.
Yes, right.
Yeah?
I know for me it was a major revelation to run into your writings and teachings, because it resonated so well to what I knew was true and that I wasn't getting from the ordinary sources.
You see, the understanding comes in the stages. You can't understand everything altogether. Desiree was with me on Monday in the office. We had a girl who flew in from Norway. Yeah. She has a MS, very young, in her early 30s. And we've been building MS system for people to trying to find a solution for MS. 6-7 years ago, I was very happy if I could get people with MS moving their legs or their feet and whatever, because I looked for physicality. And it's taken me 10 years, more or less, in researching MS and that kind of thing. While I was putting the system on for her, I realized how far away from reality I have worked, even with my research, because I ignored one of the most principal things which leads to production of MS. You understand? Leads to causing MS. Now, I built a system for her which is totally different than before, but still it's a halfway house, because while I was putting, I learned more, exactly what to look for, I hope a step further, but I don't have that much knowledge to make the system. But I know what system I have to make, that in reality it should be the size of a cup to sort the MS out. Not these shoes and helmets and the things which we reverse. Because I did what you did, I went for physicality. But in the process of learning, now I know where the gap in my knowledge has been, or I looked in the wrong direction, or I didn't have enough knowledge to see the next step. But is this a step, the final step? I don't think so. Because now, from what I understand, with the structure of the human body, exactly how you're learning from YouTube, is even you can give me MS without me knowing. I don't need my own body to create a disease. Other people can give you disease without them knowing. You understand? It's a condition of environment. You understand? So you have the condition of environment in a reactor. You have to be very careful. I work with these things. Don't ever stay near to them. Stay always. Whenever you run your reactor, just because you don't see things doesn't mean things don't happen. This is how I got the cancer of pancreas and liver. Yeah? I work too close. So just because you don't see anything, these things release different wavelengths. For you to see that light which is in there, it means the light has to emit to get to you. So it goes in different levels of energy. Yeah? It's better to see it further than the closest.
Right. Well, we do have a remote control for the for our magnetic drive motor here, and we're able to stand back for that kind of thing. And
you see, that pipe you have from your reactor to your pump is too short. It's too short.
Okay.
You're close to it. You have to try to use, if you have a space, try to get rid of everything on a table and leave your reactor on its own on a separate table, so it forces you to keep a certain distance.
Right.
You understand? This is the way you have to work to safeguard yourself. It's the way and then secondly, all your equipment around, most probably your ring pump, the pumps have a rubber ring in them for sealants, yeah? Very soon you're going to lose your rings because the field radiation will change the composition of the ring.
I see.
And then you find the life of your pump reduces by a factor of God knows how much. Instead of working for a year, you work for a few weeks.
Right.
I lost enough pumps and systems that I learned where my mistakes are. You have to always work your reactor remote with pipes. If you come into my lab, you see how I work. I make sure I'm always away from the reactor. Unless it's shut down, I go close.
Do you use a video camera or some sort of deal like that?
Sometimes. You see, this is like addiction. This is like you inject yourself with heroin, you go high, and you don't know what you're doing. The science and the knowledge is so absorbing that you forget the condition. You don't see the cliff, you just jump off it without you knowing. Yeah?
Yeah.
So you have to make sure the cliff is not high enough to kill you when you jump off it. So you have to put these systems, all your reactors, or anything you test, the smallest you test, always make an isolation table, what I call isolation table. Yeah? That you you enforce physical separation to protect your own health. I learned that out of Tehran because in Tehran, my reactors were 2 centimeters, 10 centimeters from me. Yeah? And then where I got hit is what was on my level, which was my liver and my pancreas. Yeah? So you have to walk away from this close monitoring. If you can make a table and increase your pipe. This pipe is too short. Soon you're going to find your pump will pack out because the energy release into the CH bond of your seals will open them up. They become like jelly. When you pick it up, you see it becomes, it's not elastic. It's not like a rubber hard. It becomes elastic like chewing gum. There is a lot of research about this is done by the Iranian head of space university. He's done this test for his PhD paper. So we looked at his research in Tehran, and you see these rapid condition releases will affect your seal. Then you see your pump doesn't work. You can't reach the vacuum you like to get.
Right.
Because as you saw the glow, you see part of the physicality of the glow. The rest of it is going in the pump.
Right.
Yeah. So you try to build
first thing we said when we saw that is, this doesn't seem like a good thing.
No.
So
it is a good thing, but you can learn a lot of things from it. You use your pressure cooker, use the pressure cooker, for example, to feed the gas in, to feed the gas out, and put a valve on either side. When you reach a high vacuum, you close your pump, and you keep the vacuum there, and you always vacuum in a different chamber and release in a different chamber. You have to.
Like a buffer, basically.
So you need 2 buffers, yeah. So you separate your chambers. One vacuum chamber should never be connected with the release chamber. Because the release chamber always, 100%, releases transition level magnetic field. Yeah? High energy field. Because it's very much, how can I explain it? You know, you throw a jet of water in the air and you try to catch it. You can't catch all the water which is in the air. You catch some of it. Yeah? When the plasma closes, it catches some of it. The rest of the water which is flying out, it becomes available into your system. So you don't want it to go back in your pump to damage your pump. You always vacuum in a separate chamber, and you always allow the chamber outside to be at least 10 or 15 minutes before you open it into atmosphere. Because it takes about that much for the transition energy to be absorbed by the structure of your container. These are little safety things you do. You protect your system, you protect yourself, and you have a very smooth running system. You enjoy playing with it, and then you see different structures. And if you can buy, like the pressure cooker you have is fantastic, because if you use this as a outlet chamber, not the inlet chamber, every now and then open it up and have a look what's inside it. You find new materials, you find new things.
Right.
Yeah?
Cool.
It is very interesting because I do that quite often myself.
Hopefully we won't find something more intelligent than we are in there. That's what we're worried about.
I'm doing that in my lab. They are interesting. I'm creating new life in biological side. I'm creating new life in the lab because I have understood the structure of the creation in the universe. So I have created the condition when life started on Earth. And you see it. You see the proteins, initial proteins are growing, and one of my sons was going through my lab and says, "Oh, what animal is in there now?" I said, "Okay."
Well, that's right. That's been a real eye opener for me too. I've gone through 40 years of science and thinking and so on in the last decades, but I never heard anyone claiming to know how to create life, let alone creating life. But you've laid it out in a very logical, more or less easy to understand method and way. And I thank you very much for enlightening me in that regard, as many things I've learned in the last few years from your writings and teachings and so on. So once again, thanks very much.
You're welcome. What is interesting, try to understand the condition which the material or the effect is created. Then you find you don't need to fight. It's very easy to do to replicate it. Understand the interaction of fields. Then you understand very easy how to replicate it. If you work in a matter level, you walk a hard path up.
Right. That's the way I'm understanding it now, is you have to think in different categories with this stuff.
No, you don't have to. You have to think the way universe works.
Right.
And the rest is easy.
Correct.
I don't think God to spend that much time to create things. He just puts things in the place and it happens. It's nearly 8 o'clock. I've been online nearly 2 hours.
Yes.
I have a heavy day ahead of me. You're welcome. Mr. Ludmil.
Yes, thank you very much.
You're welcome. What I would like to do, if you want to do, we do the next session in your lab.
Okay, sure, yeah, we can do that.
Yeah?
Yeah.
And then next month we come back to Rick and see how far he's gone, or we work together in different ways.
Yeah, you gave us some nice clues, Mr. Keshe. Thank you very much.
Yeah, thank you.
You're welcome. Yeah, if you can put this on the net that people can learn from it, it'll be fantastic.
That's why I wanted to ask you too if we have full permission to be able to use any of this.
This is how we start teaching. We teach the world together at the same time.
And there's nothing that we said that you want to hold back on or anything. It's all public consumption.
If it is not, it's let them copy. That's the whole purpose. The more they copy, the safer we are.
Yeah, the whole copyright
right.
system is sick, yeah.
So send me the link. We put it on the forum as well.
I'll probably get several movies out of this as well for my YouTube channel. So, yep.
Nobody is wrong. This is the beauty with this technology. It doesn't mean you're doing anything wrong. You're doing it your way, and your way is as good as mine. But we have to understand each other's work and how we benefit from it, from each other's work. So on that morning, 2 or 3 hours we spend in evaluating what we learn and what we know from each other. And I'm sure we'll have a scientist from Poland who's very advanced in his reactor. He's joining me very soon in the Keshe Foundation lab to work with us because he's very advanced in development. So most probably you meet him in the presentation in the lab. Okay. I'm sure soon we have NASA scientists on our labs as well. They will come on board.
Right on. Great.
Well, I need to do some major changes in what I did to what we speak.
No, we learn from you the way you do it.
I will do some other stuff. I will get rid of this big chamber and make...
We're always changing things. It's never the same day twice. You must have the same problem too, Mr. Keshe, where you would like to have the same reactor twice, but you like to try a new experiment each time.
I always say to my wife, these systems are like mistresses. They attract you in different ways, huh? But these are safe. They don't cause you headache. They just give you illness. But you spend all your time thinking about them and working with them, and then you forget you have a wife.
Yes, and a life.
Yeah, and my wife says, at least I know in there is nobody else but you and your machine. I'm safe. So we play with it. We're all scientists. We do the way we like to participate and feedback. So in a couple of weeks we make a date and we do it in Ludmil's lab.
Right. Okay, sure, yeah, we can do that.
Have a nice day. Thanks very much for all your time.
Thank you
very much. Have a great day. Thank you.
Bye-bye.
Nice meeting you, Mr. Keshe. Looking forward.
You're welcome. Bye, Desiree.
No, not bye with me. I have to talk with you.
I'll call you back on the separate line.
Yeah, okay.
Bye, 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 bye.
Bye. Thank you very much again.
Bye. Bye. Bye to your bird too.
Wow! Cool!